Hi, I'm Julian from IXL with Julian. In this video, I'd like to go over the probability of dependent events. This is the third installment of my probability series, and I will link the other two videos at the end of this one. In this video, we will define probability, we will define the probability of dependent events, we will do 2 examples on the board, 3 examples in IXL, and then we'll come back here for a recap of today's lesson. If you do happen to enjoy this video, please consider subscribing, as it helps out a ton and pushes these educational kinds of videos to a wider audience. Thanks, and without further ado, let's get started defining probability. We covered the definition of probability in the other 2 installments, but for review. Probability is how likely something is to happen or is true. The higher the percentage, the more likely it will happen. Probabilities can be written as either fractions or percentages. For a probability displayed as a fraction, it is the outcome we have, or the outcome we want, over the total number of possible outcomes. In our last video in our series, we covered the probability of independent events. Now we are moving on to the probability of dependent events. Dependent events in probability are events where the occurrence of one affects the probability of occurrence of the other. If 2 events, the first event and the second event, are dependent, the probability of both events occurring is the product of the probability of the first event, the probability of the second event after the first event occurs. Now to the board for some examples. Welcome to the board. I have 2 questions for us, and let's get started with the first one. There are 4 cards, 2 diamonds, 1 spade, and 1 club. If you pick 1 card, don't return, probability picking diamonds. Alright, so what is the probability of picking diamonds originally for our first probability? Well, we know that there's 4 total cards, so we're going to put that in our denominator, and there are 2 diamonds, meaning 2 out of the 4 are diamonds, meaning 2 out of 4 is our probability for picking a diamond. Now, as stated before, for these kinds of questions with dependent events, we're going to assume that we got our probability and that we picked a diamond. And now we want to pick another diamond. So what's the probability now? Well, since we've already taken a card and we're not returning it, now we only have 3 cards. So I'm going to put that in our denominator. And since we picked a diamond, and originally there was 2 diamonds, now there's only 1 diamond. So we only have 1 diamond and 3 cards. Just going to make that 3 a little larger. Okay, so now, the same as independent probability, we're going to multiply these 2 probabilities together. The result is 2 out of 12 or 1 out of 6, if you want to simplify it. Now let's go to our second question. There are 2 blue and 3 red marbles in a bag. You pull out 1 marble and don't return it. What is the probability pulling blue then red? Okay, so this is a little different because we're picking 1 and then we're picking the other kind. But we're still using the same logic. So 2 blue, 3 red, which means if we add them together, we have 5 total multiples. Okay, so we're going to put that as our denominator. Now, first we want to pull out a blue. So there are 2 blue, meaning 2 out of the 5 is our probability for picking a blue. Now, again, we're going to take 1 out as if we've gotten our expected result. So now there's only 1 blue, and there is 4 total cards, or marbles, sorry. Okay, now there's only 1 blue and there's 3 red. So what's the probability of picking red marble? Well, since we have 3 red and it's not been affected in any way, we're going to put 3 as our numerator. Now, same as the first question, we're going to multiply them together, and we're going to get 6 out of 20. If we want to simplify that, we get 3 out of 10. Now, to IXL for some more examples. Welcome to IXL. The first question says, you pick a card at random. Without putting the first card back, you pick a second card at random. What is the probability of picking a 6 and then picking a 6? Okay, so what we're going to do here is the first probability multiplied by the second probability, which occurs after the first probability has happened. So I'll explain this a little more. So for our first probability, we want to pick a 6. Now there's only one 6 and there's 4 cards. So we're going to put 1 in the numerator and 4 in the denominator, because there's 4 total cards. Now, what I mean earlier is, now that we've picked the 6 and we're not returning it, now there's no 6s and there's only 3 cards. But we can't pick another 6, which means it's 0 out of 3, meaning that you just physically can't pick 6 and then another 6. So our answer is 0%. You pick a card at random. Without putting the first card back, you pick a second card at random. There's a probability of picking a 4 and then picking a 2. Alright, so to pick a 4, it's only one of the options out of 3 total cards. So we're going to put 1 out of 3. Now, after we've picked the 4, we're going to take that away. So the 4 is not even in these 3 cards anymore. And now we only have 2 cards. So we're going to multiply it, and we're going to put 2 in the denominator. Now, 2 is one out of the 2 options. So we're going to put 1 in the numerator. When we multiply these together, we get 1 out of 6. And that is our answer. Okay, you pick a card at random. Without putting the first card back, you pick a second card at random. What's the probability of picking a 5 and then picking a 2? Answer is a fraction or a whole number. Okay, so to pick a 5, it's only 1 out of the 4 different cards, because we only have 1, 5, and there's 4 total cards. So we're going to put 4 on the denominator, and we're going to put 1 in the numerator. Now, we're going to assume that this event has happened, and we're going to remove the 5 from the deck, and now we only have 3 cards. So we're going to multiply that, and the denominator of the second fraction will be 3. Now, what's the probability of picking a 2? Well, since there's only 3 cards now, it's 1 out of 3. Now, if we multiply that together, we get 1 out of 12. Now let's go to the recap. Welcome back. In this video, we learned how to calculate the probability of dependent events. We do this by multiplying the probability of the first event times the probability of the second event as if the first event has happened. We did 2 examples on the board and 3 in IXL. Thanks for watching, and again, if you just happen to enjoy this video, please consider subscribing, as it helps out a ton and pushes these educational kinds of videos out to a wider audience. Thanks again. Bye! For the first video of the probability series, click over here, and for the second video in the probability series, click over here.